So, hi everyone. Welcome to this third video in the Verilog series and the second video in the arrays. In the previous session or in the previous video, I have discussed about the packed array. If you are having any doubts, please do check with the same video in the playlist. So in this video, I'm going to discuss about the unpacked dimension or unpacked array. So for suppose coming straight to the point, for suppose if you are declaring a variable like reg, and if you are taking the name of an array like array, if whatever the dimension you are going to mention it on the right hand side of the variable name is called as the unpacked array. The name itself is telling that the packed is nothing but it is packed in a single variable format, but unpacked is not packed in a single variable format. It's separately unpacked. We will also prove this point. But first of all, to just take an example, let me consider 3 down to 0. So whenever I am taking reg array of 3 down to 0, the compiler will assume and stack. So it will divide it into 4 parts: 1, 2, 3 and 4. So whatever the value which has been here will be assigned at this point. So it will be 3. So whatever the value which is here will be assigned to the least value, which is 0. So 3, 2, 1 and 0. This is how we are going to give an value for this is how the compiler will assume an unpacked array. So in order to understand this unpacked array, let us write a very simple code to analyze it. So let us take this module test underscore unpacked array end module. So here we are considering it as reg. As it is earlier we have taken it as p array. Here we are going to take it as up array, unpacked array. Okay. So here, as in the example, let us consider it as 3 down to 0. So let me take the initial, begin and the end, which states that it is a procedural. We need to take the procedural assignment than the continuous. This can be declared in the wire also, but for whatever the display statements and all the examples which we are considering, the procedure will be a better choice. So that's why in order for a simple understanding, I have chosen the procedural. So let me take this up array equals to 10. I think this is what we have done in the last one. Okay. And let me take it as $display up. In the last video, I made a mistake in this. So that's why I'm correcting myself. Is equals to up array. Okay. So now let us run this code. So after running this code, you will be surprised to see some error. That is illegal reference to the memory. So indirectly, the compiler is telling us that the unpacked array is nothing but a memory. The unpacked array is nothing but a memory. So that's the reason I can't represent or I can't directly print the values of an unpacked array. Okay, and you can see that the mistake is in the 9th line. The 9th line specifies the $display. So for the unpacked arrays, an unwritten rule is that for the unpacked arrays, we cannot use a direct display statement. This is with respect to the Verilog, and in system Verilog, a new operator has been introduced that we will discuss at the end of the video. Okay, so now, so whenever you are considering up array, what should be the maximum size here? See, you can see that whenever the compiler is telling that the unpacked array is also called as memory. So what is a property of a memory? If for suppose you are storing in one address and you are storing in the second address, whenever you are trying to retrieve, you will get the value which is there in that corresponding address only. The next data will not come to us. So similarly, whenever you are trying to read it in the address 0, whatever the value in the address 0 will come to us. The value in the address 0 is nothing but, as nothing is being declared here, it's a 1-bit value. So similarly, the address 1 is a 1-bit value, and similarly the address 2 is a 1-bit value. Similarly, the address 3 is a 1-bit value. But the only thing we need to remember, which is different with respect to the packed array, is in the packed array we were able to represent it in a single pack, but here we cannot represent it in a single pack. So in order to prove it, I think we have used this particular example. Now let us take a possible use case for this. So let me take it like, see, the maximum possible value is 1. So let me take an integer I, or else let me directly use the value instead of for loop. Yes. So this is going to be the first, second, third. So here let me consider this is 0, this is 1, this is 0, this is 1. Okay. And based on the previous, I can't use this display statement. So obviously I need to use the display statement. In order to use the display statement, let me use an integer I. So here it's going to be for I is equals to 0, I less than, what is the maximum size of the unpacked array? 4-bit. So the dimension is nothing but the 4. So I'm taking 4 here. Next, as I++ will not be available in the Verilog, I am taking I equals to I plus 1, begin and the end. So here I'm just considering this like percentage 0d is equals to percentage 0d, and this is going to be I comma up array of I. Now it shouldn't throw any mistake because we are reading the memory location separately. Now let's run the code. So here you can see that whatever the values which we have given here, we are getting it the same. So instead of using the memory, we have displayed all the contents of the memory location separately. So indirectly, we can just assume that whatever the unpacked dimension will be nothing but the memory. So as we have discussed, will be so we can also represent this unpacked array in terms of reg array of 0 down to 3. Okay. So as per our analysis, what will happen if we are assuming it as 0 down to 3? So generally the compiler will consider it as an memory block. So whenever it considers as a memory block, based upon this particular unpacked array value, we are going to get this. So here this value is going to be, this value is going to be the 0, and this value is going to be the 3. So generally the students or some people may feel like, what will be the difference if I'm taking 3 and 0, because it's a memory, I'm declaring them separately. This difference you will observe it while working on the multi-dimensional arrays, while discussing what should be the value. So that's the reason I have taken in the similar way as the compiler is going to assume. So here this is 1 and this is 2. So the max bit here is going to be the 1 bit. Here also it will be 1 bit. Here also 1 bit, and here also 1 bit. Now in this particular example, let me change the same and let us check it. So this is 0 and this is 3. But here you cannot find much difference, because but you can find that much difference with respect in the multi-dimensional array. But here you can see that whatever we have given above are coming here. Okay. So This is the thing. And in our discussion, I made a discussion like we can display all the contents of the array even for an unpacked dimension using dollar display. That can be done by using the percentage p operator. Okay. So in order to just see a demo, instead of using this for loop, just above the for loop, let me take a dollar display statement. And in this, I'm just going to consider this like percentage p. And here I'm directly declaring this up array. Okay. Now you can see the magic. So here you can see that directly whatever the contents of the array are displayed separately. So yes, so this is the percentage p operator, the use case of this percentage p operator. So in the next video, we will discuss about the combination of this memory as well as the packed array. So which is nothing but a multi-dimensional array. So please like, share and subscribe to Beacon Preceptor. And if you're having any advices or suggestions, please do ping in the comments below. Thank you. We will meet in the next video. Thanks a lot.